Alright, this is Precalc concept 8e. I'm talking about vertical stretches and shrinks of a function. 4 boxes. Box 1 is a concept. This is straight out of your book. If we look at this statement down here, we're going to be looking at a function f again. This time our change is going to be a multiplier. So we're going to let c be a positive real number. And if you have a multiplier out in front, like that c right there, what will happen is your graph is going to be vertically stretched or shrunk depending on the value of c. So what you're going to have to keep straight here is that if c is a number bigger than 1, you're going to see a graph that's vertically stretched out. You can see this one down at the bottom is stretched away from the x-axis in all directions, and that is a vertical stretch. In the second example, when you see a c value that's between 0 and 1, so a good way to think about that is a fraction, like a half or a third. Your original graph is going to be shrunk down towards the x-axis. Basically all the y-coordinates of the function get multiplied by c. If c is a number bigger than 1, you're going to see it grow or stretch out vertically, and if c is a fraction between 0 and 1, you're going to see the y values shrink down. Alright, box 2 is an example. We're going to look at our x cubed function. I've got a graph here straight from Desmos. I was able to label 3 points. We're going to track what happens to those points. When you do a new and related function, in this case 1/2 x cubed. So you should recognize those as very similar functions. The only difference is you have this 1/2 multiplier out in front. Okay? Let's start with our points. So every single one of our points is going to be changed, and it's the y-coordinate that's going to be changed. And our new point is going to simply be the y-coordinate multiplied by 1/2. So this point 2, 8 will be transformed into a point 2, 4. And the point 1, 1 will be transformed into 1, 1/2. A little bit hard to show there. And then finally -2, -8, if I multiply that y-coordinate by 1/2, I get -2, -4. Okay, again, all the y values are going to be affected in the same way, so you have to imagine doing that kind of across the board. What I end up with is a very similar looking graph. However, everything's kind of been vertically shrunk, so we're going to see a graph that's basically flatter, and that is our h of x graph. Okay, box 3, another example. We're going to look at our absolute value graph. That's a common function. And then think about how multiplying it by 5 changes the function, right? Again, our change is a multiplier. This time it's a number bigger than 1. What I'm going to expect to see is a vertical stretch. Every single one of my y values is going to be multiplied by 5. So the point 3, 3 is going to go way up here to 3, 15. Point 1, 1 is going to be stretched out. That's going to become 1, 5. And -2, 2 is going to become -2, 10. So tracking these points helps us kind of see what's happening. We then have to interpret that that's going to happen to every single point on the function. And when you do that, you're going to get a graph that's stretched vertically. Losing the shape of my V a little bit there, but we're just doing a sketch, so I want to capture that pretty well. That is my h of x function. A lot of people describe this as a skinnier graph, which is true, but the way we want to think about it really, when you have a multiplier like that, is a vertical stretch. So think of it as being stretched out is a good way to think about this transformation. Okay, box 4 is a u-try. Once again, I'm going to give you kind of an unusual function, so not one you're familiar with, but you should be able to still interpret how the graph of g of x is just slightly different from the graph of f of x shown below. Take a minute, think about what your sketch would look like for the g function. Alright, you should get something like the red graph below. Tracking those points, negative 2, 2 is going to become negative 2, 6, and 2, negative 4 is going to become 2, negative 12. Everything is vertically stretched out. Good to note that the 0 of this function, where it crosses the x-axis, is unchanged because the y-coordinate of 0 is multiplied by 3, but that remains 0.